Okay. 5.2, evaluating and graphing polynomial functions. Okay. There are some clues on how we graph polynomial functions. Last chapter we did quadratic functions, yes? And so they were squared functions, they made a parabola type shape and all that. Polynomial functions can have different forms to them because they can be quadratic, they can be cubic, quartic, any type of thing, okay? Linear, constant. A polynomial is a monomial or a sum of monomials, so a polynomial function is a function of the form, okay? And the form is a sub n x to the n, a sub n minus 1, x to the n minus 1, it keeps going on and on. Basically just saying, if I have 6x cubed, then the next thing would be squared, then x, then nothing, okay? If you have a degree of 0, you have a constant graph, okay? And it's represented by f of x equals a sub 0. So it would be like just graphing a number, negative 14, 7, 12, 3 seconds, things like that. If you have a linear equation, you know it in the form of y equals mx plus b. But linear is f of x equals a sub 1x plus a sub 0. And you have f of x equals 5x minus 7 as an example. Quadratic, you know it, it has a degree of 2. F of x equals a sub 2x squared plus a sub 1x plus a sub 0. F of x equals 2x squared plus x minus 9. Cubic would be a degree of 3, and it's f of x equals a sub 3x cubed plus a sub 2x squared plus a sub 1x plus a sub 0. See how it constantly is just counting down. That's the whole point. Okay, f of x equals x cubed minus x squared plus 3x. These are all examples. And then quartic, degree of 4. Okay, same thing. An example is f of x equals x to the 4th plus 2x minus 1. Remember that you don't have to have a cube and a squared in there. You don't even have to have an x in there. You can just have x to the 4th and it's still quartic. Okay, or vice versa for any of them. Just some little things to remember. So, we want to first classify things, decide if they are polynomial functions, and then if so, we want to tell the degree, the type, and the leading coefficient, okay? So right here you have x to the 4th minus 1/4 x squared plus 3. Is that a polynomial function?
No. Yes.
What do you think?
Yes.
Yes.
You say yes? Okay. The function is polynomial. You're correct. What degree is it? The degree, you just gotta give me a number. 4. The type, you tell me. Quadratic, yes. And then the leading coefficient would be 1, because that's what's in front of x to the 4th. B, 7x minus radical 3 plus pi x squared. Is that a polynomial function? Yes or no?
Well, yes, it's just.
B. Yeah, that's a polynomial function because I go squared, x, and then just a number, yes? Okay? It matters, to tell if it's a polynomial function, it matters in the power, what's going on there,
So
basically.
it doesn't matter.
Well, we can rearrange it to put it in standard form. So if I rearranged it, it would be pi x squared plus 7x minus radical 3, okay? So that is a function. What is the degree? 2. 2 is your degree. My degree is what my power is. So my highest power is 2, okay? What type of function is it? If it's squared, what type of function is that? Quadratic. 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 And then what is my leading coefficient? Pi, okay? Part C, 5x squared plus 3x to the negative 1 minus x, is that a function? Is that a polynomial function? What? You say yes. And any other votes? Yes? It is not a polynomial function. What is going on in that power? Negative. I cannot have a negative power in a function. Okay? So I cannot have a negative power. So that is not a polynomial function. Okay? Because the term 3x to the negative 1 has an exponent. That is not a whole number. You have to have a whole number for it to be a polynomial function. Okay, part D. You have x plus 2 to the x minus 0.6 x to the 5th. Is that a polynomial function? Why not, Kaden? x, you have to have a whole number for it to be a polynomial function. Okay, so both C and D are not polynomial functions. Like I said, we're gonna break this into 2 days. Okay, we're gonna do something called direct substitution, okay? To evaluate f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8. What do you think direct substitution means that I'm doing? I'm substituting something in directly, like straight to that spot and getting to the point, okay? And it wants to know, it wants me to evaluate when x equals 3. So what do you think I'm gonna do?
X.
Put 3 in where there is a x, okay? This is what is called direct substitution. I'm directly putting 3 into x. So I have this, 2 times 3 to the fourth minus 5 times 3 cubed minus 4 times 3 plus 8. So this is plus 8, this is minus 12. What's 3 cubed? You're gonna need calculators today because I don't think you can do some of this math in your head, or we don't want to because it's like 27. And then times negative 4 gives me negative, or not negative 4, I'm sorry. 27 times negative 5, yes? Gives me negative 135. And then 3 to the fourth is what? And then times 2 gives me, so I'm gonna do 162 minus 135 minus 12 plus 8, and you're going to get an output of 23. There's direct substitution. Okay? All of you can do direct substitution. You can do that. You've done it before, but this time they're gonna give you specific instructions that says use direct substitution to solve, okay? Because we're gonna talk about a different substitution next. We're gonna talk about synthetic substitution. Personally, synthetic substitution is probably my favorite way to solve something because in problems that are larger, where it's more than a fourth power, okay, it's a fifth, a sixth, you can just keep using synthetic substitution until you get to all your factors. So it just makes life a little bit easier, okay, or until you get to a remainder. So synthetic substitution, okay, is shown right here. So if we take the same problem that we just had, 2x to the fourth minus 5x cubed minus 4x plus 8, okay? To do synthetic substitution, I'm going to take that 2 that's in front of the x to the fourth, okay, and I'm going to write it out. Then I'm going to take the negative 5 that's in front of the cube. What is missing? It goes 4, 3, 2. Do I have anything where it should be squared? That's where that 0 comes in on the board. I have to put a placeholder because I have to count down all my x's, okay? So anytime anything's missing, you put a 0. So that represents squared. Then I come with negative 4, and then I come with 8. Here's synthetic substitution. Now, x equaled 3, so I put a 3 on the outside here. Here's how this works. You bring down this first number, which is 2. Then you say 2 times 3. What's 2 times 3? 6. Then you add these insides. Negative 5 plus 6 is 1. Then I come back over here and I do 1 times 3, which is 3. I add those together and I get 3. Then you do 3 times 3, which is 9. You add those together and I get 5. Then I do 5 times 3, which is 15. And what is 15 plus 8? There's my answer. Did I get the same thing? Personally, this is easier when it's a straightforward problem like this. Later on, when it says list all the factors of this, synthetic is going to be simpler, okay? So we practice it with easy things first and then we move on from there. Okay. What time do we get out of here? I gotta keep an eye on it. Oh, we get out at 12:52, 20 minutes. So here's the deal. Now, with synthetic substitution, we can start to solve stuff. And like I said, tonight's homework is gonna be easy synthetic substitution, but we're gonna use this later on in the year more and more, and you're gonna like it more because we're gonna have to factor that by using synthetic. And then we would keep going from here, and we would keep going, and we keep going, so that we could get all of our factors, okay? In behavior, we need to talk about in behavior. You need to memorize this chart. This chart is on page 339. Okay, write that number down, 339. It's gonna help you on your homework. But you need to understand what's happening so that you know when we go to graph stuff by hand, what it should look like. That way you can catch mistakes. If you plugged in numbers wrong and got the wrong outputs or something, you can catch your mistakes if you know what your graph should look like, okay? Because you can be like, that ain't what it's supposed to look like. 339, okay? So, you're in behavior of a polynomial function. If your degree is odd, meaning your highest degree is an odd number, cubed, seventh, fifth, anything like that. If it's an odd number, your leading coefficient is positive, bless you, then your graph is going to look like this N basically, okay? Down here it's gonna go negative input, negative output. Up here it's gonna go positive input, positive output, okay? If your degree is odd, but your leading coefficient is negative, it mirrors that graph basically, okay? A positive input gives you a negative output. A negative input gives you a positive output, okay? Degree meaning your highest power. So if my highest power, like right
So
here,
if it's a 3,
yes, if
oh,
it's
that's.
3, 5, 7, 9, anything that's an odd number. 1, okay? If I have an even degree, such as this one right here where it says to the fourth, okay? If I have an even degree and my leading coefficient is positive, okay, then I have a positive input, a negative output. I have a positive input, a positive output. It makes a W. So this one should make something that looks like a W when I graph it, okay? When you have a degree that's even and you have a negative leading coefficient, it's negative, 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 positive, okay? It switches, so instead of it being a W, it flips down to look like an M. Now, the amount of curves that happen depend on what power you have, okay? If I have a fourth power, that means I could have up to, but not, I don't have to have this many, I could have up to 3 curves, which is why I could have a W, because that has 3 turning points, right? Like when here, here, and here are turning points. I could have up to that. It doesn't have to be that, but I can have up to that. If I have something that has a 7th power, how many turning points could I have? 6, okay? So those are some keys on how to decide what your graph might look like. So here, it gives us a graph. And it says, what's true about the degree and the leading coefficient? What do you know about the degree of this? Is it odd or even? Even. And what do you know is the leading coefficient negative or positive? Negative. So you have a negative leading coefficient and an even power, okay, because of the type of graph it shows. Okay, now it says use synthetic substitution to evaluate the polynomial function for the given value of x. So, somebody tell me, how do I set up synthetic substitution for number 6?
2 on the outside.
2 is on the outside, okay. What goes inside?
And then
5,
3.
3, and 7. Now what do I do first?
2.
Yeah, bring down the 5. 2 times 5 is 10. 10 and 3 added together is
13.
13 times 2 is 26 plus negative 1 is, and 25 times 2 is, and 50 plus 7 is. So I solved using synthetic. 57 is my answer. Okay, 57 is my answer. Now look at the next one. How do I set that up?
Negative 1 on the outside.
Good, negative 1 on the outside. What goes on the inside? Negative 2.
0.
Negative 1, then 0, then 4, and then negative 5, yes? Bring this down. What's negative 1 times negative 2? 2 plus negative 1. 1 times negative 1. Negative 1 plus 0. Negative 1 times negative 1. 4 plus 1. 5 times negative 1. Negative 5. And negative 5 and negative 5 is, so I get negative 10 out. Okay. at number 8. Describe the degree and leading coefficient of the polynomial function whose graph is shown. What type of degree do I have?
When you graph it, is it just like taking the x and y? Like -1 would be the x and -2 would be the y. Is that how you graph it?
Yeah, this is my x, this is my y. When I plugged -1 in, I get -10 out. So when I'm using synthetic, I'm technically plugging this in. This is what x equals. When I plug that in, this is what you get out. Okay. So on that picture over there, what is the degree? Odd, good. And then what type of leading coefficient do I have, negative or positive? Negative, beautiful. Okay. That's where we're gonna stop, because we're gonna work on graphing, like putting the graphs together tomorrow. Okay, tonight I just wanna get used to this stuff.